with Oscar class. That's my dad.
Alright, so far we've been talking about inequalities, what they're set up as, and what they function as. Now we need to start looking at how to actually solve inequalities for a missing variable. Remember, whenever we're looking for a solution, we're looking for the value or values of x that make the overall statement true. Let's take a pretty straightforward example then. So, we'll start off with x plus 3 is greater than or equal to 4. Now, I'm going to pretend, for our purposes, that I'm looking at an equation, not an inequality. So I'm going to be subtracting 3 from each side of this. So subtract 3 from both sides. Like everything else we've done, we still have to make a note of what we're doing in words that matches the work on the page. So now this comes down and I end up with x is greater than or equal to 1. Now, I've got x isolated on one side of the equal sign. I've got a value on the other side, or the inequality symbol. I'm more or less done with coming up with a solution. But now we need to put our solution into some kind of context. So this reads, x is greater than or equal to 1. So our set of numbers are all the numbers 1 and up. If I were to put this on a number line, remember you're going to be expected to graph these solutions as well. There's 0, there's 1. Now, it's equal to, so 1 is a solution. I also want greater than, which means I'm going to be going off to my right. There would be my solution. Now, let's do a quick check. Does 1 make this statement true? 1 plus 3, is that greater than or equal to 4? Well, it sure seems to be. 4 is at least equal to 4. That's a true statement. Let's take another number over here, like say the number 5. That's in my shaded region. 5 plus 3 is 8. Is that greater than 4? Checks out. So 8 is a solution. In fact, all numbers greater than 1 are solutions. All right, let's take a look at another inequality that we can try to solve. Remember, we need to also be writing out our steps in words so we can go back and review it later. And our solution must be given as more than just an inequality, but shown on the number line in what we call the graph. So, here's our inequality to solve. Now it says x minus 5, so I want to get rid of this on this side of my scale. I'm going to bring it over to this side by adding 5 to both sides. Alright, now, this side simplifies to x is less than 15. The only thing left over here is my x, the only thing over here is my 15. So that means any number which is less than 15 is going to make this overall a true statement. Now let's do the graph. There's a number line, there's 0, there's 15. Now I'm looking for all the points less than 15. Now if we're not sure, let's check. Is 15 going to make this true? 15 minus 5, is that less than 10? Is 10 less than 10? Well, that's not true. 10 is not less than 10, it's equal to it. So we make a mark there that says, nope, that's not going to work, and we can't involve 15 as a potential solution. So I'll make an open circle here to represent the fact that 15 is not a solution. Now I want less than, so that's going to go off this way. Now, if I'm not sure, I can always test another point. Let's test the point 0. That's an easy test point. 0 minus 5, is that less than 10? Is negative 5 less than 10? And that checks out. So a solution would be 0. And I can, of course, check any point over here that's less than 15, and I'll continue to get the correct answer. I'll keep getting things that do indeed work. So this would be my solution as an inequality. This would be my solution as a graph. You are expected to be able to write both. Now the good news is we're going to try to keep the algebra portion of this, getting from here to here, fairly straightforward. So what am I worried about? Can you get me this number line as well as this inequality? Another way to think about this too is that we're still trying to keep scales here. The difference is they're not balanced because it's not an equation. So there's not a single number in that box there's a whole collection of numbers that could still make this true by keeping the scale tipped one way or the other. The last mnemonic I'll mention, there's no line under here. I think we've mentioned this before. If there's a line under the inequality, you fill the circle in because there's extra stuff. There's no line, so there's a minimal amount of different stuff there, so we only make an open circle to help represent that. It's another good memory aid to remember how this all goes together. Let's take a look at the third example, and then we'll move on. All right, our last inequality now is going to be y less than 4, y minus 4 is greater than 6. Now again, I'm going to stick with what I know works when it comes to writing inequalities or solving equations. I want to get the 4 off that side and bring it over to the other side. So what I'm going to do is the opposite. I'm going to add 4 to both sides. Y is greater than 10. Now I got to write the graph. There's 0, there's 10. Now I want y greater than 10. Now there's no line under it, so I'll make an open circle. And then I got to ask myself, am I going for numbers to the left or to the right? Well, if I think about it, let's just for giggles, let's test the point 12. 12 minus 4, how does that compare to 6? That gives me 8, which is greater than 6. And so that checks out. So that means that 12 must be a solution. I can try some other numbers. As I keep trying numbers, I'm going to notice that 11 works. 11 minus 4 is greater. I can test out 13. It'll check out. Everything over here checks out. What does not check out are numbers over here. Like if I were to try 0. 0 minus 4 is negative 4, and negative 4 is not greater than 6. And if you ever get stuck, remember, Pac-Man always eats the bigger dot first. So this is telling me that this side of the equation must be bigger than this side of the equation, which is why 8 greater than 6 checks out. It's another little memory aid to help keep all these inequalities straight. All right, so now I've got my solution as an inequality, my solution as a graph.